Having dealt with Mercury, we now move on to the next planet, Venus, or a planet that I call, which is in its formative stage of planetary evolution. This planet is beginning to show signs of movement away from the developmental process of Mercury, but is not quite at the developmental stage, which I call the generative stage, which is planet Earth. There's a critical factor in this planet, its formation, and this formation is based on the introduction of only one element into the mix. Initially, we had spoken about nuclear transmutation, the decay of uranium. Now, I said earlier, I do not want to get too technical as far as this is concerned, and I will keep it as simple as possible so that someone who has not done chemistry would understand. Uranium, the element, which originally was what I indicated was the formative material of the crust of Mercury, begins to decay. Uranium takes 4.6 billion years to decay to lead, and that is common knowledge. As we discussed with carbon and lead and nuclear transmutation in the last recording. As we move through the decay process, a critical element is formed, almost, you can say, halfway through the process of the decay of uranium. And that element is polonium. Polonium was discovered by Pierre and Marie Curie many, many years ago, and it's a radioactive element. But more important than that, it is in the same group in the periodic table, which is the table that lists all the elements. And it is possible to say that a nuclear transmutation of polonium could result in the formation of this critical element, which heralds the beginning of the formation, or the beginning of the evolution, or the next stage of evolution of a planet. This element is oxygen. The formation of oxygen from the decay of polonium creates two activities. One, oxygen then binds with an element called hydrogen, which we're familiar with, of two parts, and forms a molecule called water. Water is a critical factor in the formation of water on the planet, which is approximately, in my estimation, about 3 billion years after the uranium starts to decay. You begin to have the formation of water. Once oxygen is formed, then the next thing that is formed, because of the nature of oxygen and the ability to form molecules with itself, it forms 3 molecules and creates something we call ozone. This ozone layer, or this formation of ozone, creates a shroud around the newly formed planet that used to be Mercury, and protects it from and reflects the normal sunlight. As a consequence of that, the temperature of the planet decreases. That continues, and coupled with the formation of an element of water, the molecule of water, creates a point where there is a formation of water to an extent that it reaches something the scientists call dew point. That dew point is the time when the atmosphere becomes so saturated with water that water droplets begin to form and it begins to rain. This is the beginning of the water cycle, which is also a component in further cooling the planet, and formation of clouds further protecting the planet from sunlight, and over a few million years reducing the temperature of the planet. As the planet continues continues to reduce, you have, by the same process of nuclear transmutation, other elements being formed. The formation of these elements creates within the system a very clear and precise series of elements that will over time begin to connect with each other. Many of you who would have gone to a volcano or would have been close to a volcanic activity would have smelled a rotten egg smell. This smell would be hydrogen sulfide, and where hydrogen sulfide is common and oxygen is common, the molecule of oxygen will remove the molecule of sulfur, allowing water to continue to form. The continuous volcanic activity, which we indicated was ongoing on the planet Mercury, continues on the new planet, the planet at a new stage of evolution. This means that you have many, many more craters forming, which we would come to know as mountains and hills. And of course, if there are mountains being formed, there would be valleys or recesses where there would be able to be the collection of water, forming seas and oceans, etc. And with the process of the water cycle, creating a situation where there is a greater understanding of a perpetual system that continues to cool the planet. As that continues, you have more and more water being formed, more and more cloud cover, a cooler planet. The key now is to watch that process and to see that process ongoing through a period of time, which will get the planet Venus closer and closer and closer over time to looking and becoming like Earth. You are correct. The environment begins to nurture the formation of life. So we have dealt in this section with the origin of water on the planet in the first instance, and the second instance, the beginnings of the origins of life. This life, as far as Venus is concerned, I have decided to deal with in another publication. But for our resources, for our use now, we are only going to focus on the planet in terms of its evolution. Let us look at the time frame. If the only time that a planet can begin to process and create water, which is the beginnings of life, is when it has decayed to about 3 billion years, it would be logical to assume that if Mercury exists in its current form, and there is knowledge that there is water on Venus, then it means that the period of time between the formation of one planet and the next planet would be about 3 to 4 billion years. So it would be fitting to say that almost every 4 billion years there is a new planet which is ejected from the sun, and there is a space created by the planet which was before being pushed further away from the sun out into outer space. As we continue to look at this process, it must be realized that there is more to just water and Venus and Mercury than meets the eye. As the planet continues to have volcanic activity, and it continues to develop volcanoes as it spins at the fantastic speeds around the sun, it means now that will cause a wobbling effect. This wobbling effect will aid the commencement of rotation. So it would be similar to a top spinning and wobbling and developing momentum. So the difference you have between the speed of Mercury, which is barely revolving at all, other than its diurnal revolution, and the speed of Venus, which is 3.0 kilometers per hour. So there is a movement where momentum has begun and the planet has started to spin. This spinning effect creates two things. One, the commencement of the motion of the planet in terms of the movement of water bodies and tides, etc. But in addition to that, it begins to create a very interesting phenomenon. That phenomenon being the commencement of gravity in a great sense, meaning causing the spinning, causing the weightedness of the planet. So as you continue to have increasing motion, things get heavier and heavier and heavier and creates the commencement of gravity. The necessity of understanding this process and the necessity of looking at Mercury and Venus and the closeness and the behaviors is to understand that if Mercury in 3 billion years, a planet became Venus-like, it means that our current Mercury will in 3 billion years become Venus-like, and our Venus currently will in 3 billion years become Earth-like. This has significance for our discussion later, and you will see that the critical factors that are important here is not an understanding of the differences of the planets, but the understanding of how remarkably similar these planets are. We move gently now to understanding what is possible. Is it possible, and these questions I will ask in this section related to Venus, is it possible to introduce oxygen into an environment and create a situation where there is greater activity and the formation of cloud cover and the ozone layer? Very important in the discussion now is to look at the understanding of how important a role oxygen plays in the development, but more so to look at the role that the other factors of initiation in the environment. One of the greatest things that we see or phenomenon in the formation of a planet is something we have come to know as lightning. This is very important, especially when coupled with certain compounds that would be very present in the formation or that stage or the formative stage of a planet. One such compound is CH3 and CH4, which is methane. And the formation of methane in its natural form, and we would have smelled methanol from petroleum, so we know it's a natural product. Given the consistency of the volcanic eruptions and the inability of the methane to escape because it would be enshrouded through the cloud covers, all you would need is enough cloud cover to rub together to form a bolt of lightning that would strike the methane coupled with the oxygen to create the spark that would generate the level of energy that would possibly begin to form a compound which would be made up of carbon, hydrogen, oxygen, sulfur, and phosphorus. What I just mentioned here, my friends, is the beginning of the formation of something called an amino acid or protein, which many would know as the beginning of the formation of life. So if life would commence in that form on Venus, you are asking some interesting questions. The first question is, can we engender this again? Can we create the enabling environment for the formation of the joints of that? Or is it just a natural phenomenon that would have happened with or without mankind's input? If you look on as we continue, you will see that more so there is more to this than meets the eye. That the development of the planet is not only a very marked, precise activity, but it is also a perfect activity. And for those persons who would look at evolution with regard to creation, as I said earlier, it is my firm belief that creation, or should I say evolution, is man's perception of creation. That the only difference between the two activities is time and a prime mover. So what do we learn? What do we see? What do we understand from the developmental process that I've outlined, which is logically and sensibly one of the few ways that will ever explain the formation of a planet such as Venus, and which will develop in our minds a very concise, a very crystal clear understanding of what perfection lies in that which we cannot see. So as we move on to the next planet, which is planet Earth, I ask you to look very, very carefully at the time frames that are involved. And as we advance, you will see that many theories that would be or would have been promoted would in fact be probably erroneous. Because a galaxy that you say is 4.8 billion years, one planet is already showing that it is 4.8 billion years. So as we advance, we will look at the time frames and how important it is to realize that the calculations of the age of our galaxy is not only based on the ability to predict light years, etc., and for many persons, very confusing times and quantities. But it is simpler than you think. And it is that simplicity that exists in many other areas throughout nature.